Kuzampola. Welcome to Bhutan e-learning program. I'm Khemraj Gale, chemistry teacher from Gedu Higher Secondary School. Today we are going to learn about electronegativity, polar molecules, and coordinate bond. A lesson for key stage 5, that is for classes 11 and 12. Now, let me read out the lesson objectives for the day. By the end of the lesson, we will achieve the following objectives. Number 1, define electronegativity and explain electronegativity. Define polar molecules. Explain polar and non-polar molecules with reference to electronegativity and dipole moment. And the fifth one is define coordinate bond, and lastly, explain the conditions required for formation of coordinate bond. Now let us look at what is electronegativity. So let me give one example here. So the bond forms between hydrogen and chlorine. A covalent bond formed between hydrogen and chlorine. So they share an electron each to complete their octet and the duplet state. And then what do we expect? We expect that when a bond is formed between hydrogen and chlorine, we expect that the shared pair of electron to be exactly in between hydrogen and chlorine. But this does not happen. So in actual practice, so what happens is the shared pair of electron between hydrogen and chlorine is more towards chlorine. So here it means to say that the shared pair of electron between hydrogen and chlorine is now taken by chlorine. So this phenomena is known as electronegativity. So let me read out the definition. Electronegativity of an element is the tendency of its atom to attract the shared pair of electron towards itself. So we see that here chlorine has attracted the shared pair of electron towards itself. So this is electronegativity. Now how does electronegativity vary in a periodic table? So I have here one form of periodic table. We see that here as we go from left to right side of the periodic table, we see that the value of electronegativity increases. We can see there from the chart, lithium has the value of 1, and on the extreme right side we have fluorine, which is assigned the value of 4. So this is the trend of periodic table across the period. Now what happens to the trend of periodic table down the group? So as we move down the group, the value of electronegativity decreases. Example here, hydrogen is assigned a value of 2.1 and potassium 0.8. So what do we see? We see that the value of electronegativity decreases down the group. So across the period, value of electronegativity increases. Down the group, value of electronegativity decreases. So one is increasing and the other one is decreasing. Now, why are some of the elements are more electronegative than others? We see that hydrogen is less electronegative than chlorine. So what is the reason? You might be wondering, what is the reason behind having chlorine high electronegativity than hydrogen? So there are two factors. The first one is effective nuclear charge. So if the effective nuclear charge is very high, then the electronegativity will also be higher. Higher the effective nuclear charge, greater its tendency to pull shared pair of electron. So chlorine has high effective nuclear charge, so it has greater tendency to attract the shared pair of electron towards itself. Example I have here, for the fluorine, effective nuclear charge is +7, and for carbon it is +4. So definitely fluorine will have higher electronegativity than carbon. Now number 2, size of the atom. So electronegativity decreases with increase in the size of the atom. I have taken the example for fluorine and oxygen. So fluorine, the value of assigned to fluorine is 4 and for oxygen the value assigned is 3.5, value of electronegativity. Why fluorine has higher value of electronegativity? This is because fluorine is smaller in size. Now if you look at the periodic table, oxygen and the fluorine is towards the right side of oxygen. So fluorine is smaller in size, so definitely it will have higher value of electronegativity. So these are the two factors which determines the value of electronegativity. Now, what happens if two atoms of equal electronegativity bond together? If both of the atom, let us say here atom A and atom B, if they form a bond and then we assume that they are both A and B are of equal electronegativity. So where will the shared pair of electron be located? Where will be the shared pair of electron between A and B? It will be exactly in between A and B. Why? Because both of them have the equal tendency to attract the shared pair of electron. So we see that the shared pair of electron remains exactly in the middle of the two atoms. We have taken here atom A and atom B. So example, let us take the example of hydrogen. The bond formed between the two atoms of hydrogen. So this is one H hydrogen atom and this is the other H hydrogen atom. So if they form a covalent bond, the shared pair of electron will be exactly in between the two hydrogen atoms because they are of equal electronegativity. See, okay. Similarly, we can cite the example for even the formation of chlorine molecule, Cl and Cl. The shared pair of electron will be exactly in between the two chlorine atoms. So this kind of bond formed are known as non-polar covalent bond. Non-polar covalent bond is formed when the atoms of same electronegativity form a bond. And then that is non-polar covalent bond. Now let us see what would happen if B is slightly more electronegative than A. Now here we are looking at different value of electronegativity. So let's look at here A and B. So here the condition is B is more electronegative than A. So where will the shared pair of electron be located? So it will be more towards atom B. Why? Because atom B is more electronegative than A. So in the meantime, so B attracts the shared pair of electron towards itself in a covalent bond. If B is more electronegative, the shared pair of electron will be more towards B side. Therefore, B has more electron density and acquires slight negative charge. So B will become slight negative charge and at the same time A becomes slightly positive. So we see that there is a development of partial positive and negative charge. So here A has developed slight or partial positive charge delta plus and B has developed slight negative charge. So delta minus. So we see that here when the bond is formed between A and B, so B is more electronegative, the shared pair of electron is more towards B. So meaning that B has developed slightly negative charge and A has developed slight positive charge. So this leads to the formation of polar molecules. So and the nature of the bond is called polar covalent bond. So remember, polar, there is a difference in electronegativity. Non-polar bond, same electronegativity. I have taken the example of hydrogen and chlorine. Okay, so plus then Cl. So when a bond is formed between hydrogen and chlorine, we have here H and Cl. But the shared pair of electron is more towards chlorine side. So in the meantime, so hydrogen develops slight positive charge and chlorine develops slight negative charge. So these are the examples of polar covalent bond. I hope the things are clear, the difference between the polar covalent bond and the non-polar covalent bond. Now, what measures the degree of polarity? So how can we say that the bond form is polar in nature or the bond has the polarity nature? Now, one of the factors is dipole moment. So what is dipole moment? It is a measure of polarity in covalent bond. Dipole moment, it is represented by mu. So dipole moment of a covalent bond in a polar molecule is the product of the magnitude of the charge present on either side of the two atoms and the distance by which two atoms are separated. So here A and B. So here we are talking about the formation of polar covalent bond. So the dipole moment. So we know that in polar covalent bond, the shared pair of electron is more towards the more electronegative atom. So here B is more electronegative. So the value of mu is equal to Q times R. So what is Q? The magnitude of charge. So here delta plus and here delta minus. So this either the charge on either A or B can be taken for the calculation of dipole moment. So Q and what is R? R is the distance between the two atoms. So the unit is dBi, which is represented by capital letter D. Now let me give you some few examples of the dipole moment for some molecules. So dipole moment, here we can see that for HCl, the value is 1.03, and for HF, the value is 1.91, and for CO2, the value is 0D. So here, what can we conclude from the given data? We can see that HF has the highest value of dipole moment, that is value of 1.91. So HF has the maximum polarity, then followed by HCl, and ultimately CO2 has the zero value of dipole moment. That means the bond in CO2 is purely non-polar covalent bond. So this is with regard to the dipole moment. So if the value of dipole moment is greater for a molecule, that molecule will have the high degree of polarity. Now let us all define together what is a polar covalent bond. A polar covalent bond is a covalent bond in which there is a separation of charge between one end and the other. In other words, we can say one is slightly positive and the other end is slightly negative. So here A and B. So if B is more electronegative, so B becomes slightly negative charge, B will develop slightly negative charge, and A will develop slightly positive charge. So this leads to the formation of polar covalent bond. So what is polar covalent bond once again? It is a bond formed between the two atoms where one atom develops slightly positive charge and the other atoms develop slightly negative charge. This is because of the difference in their electronegativity. Example, we have the formation of the bond formed between hydrogen and chlorine. So this is one example of polar covalent bond. Similarly, we have the bond formed in water molecule. So this is also an example of polar covalent bond. So based on the value of electronegativity, we have different types of bond in which we have already learned in the lower classes. Can reflect on some types of chemical bond which we have already learned in classes 9 and 10. What are the different types of chemical bonds? We have studied ionic bond and covalent bond. That is in classes 9 and 10. Now, today we will focus on co-ordinate bond. So co-ordinate bond. How co-ordinate bond is formed, or what is a co-ordinate bond? Co-ordinate bond is a type of covalent bond in which the shared pair of electron is contributed by only one of the bonding atom. It is also called dative bond. So let me explain you with the example. Formation of ammonium radical, NH4. So let me give you one example how this ammonium radical is formed. The best example for the formation of coordinate bond. So here, first it is ammonia, NH3 plus, then H plus gives you NH4 plus. So here we know that nitrogen has atomic number of 7. So the configuration will be 2 and 5. So remember, only valence electron is involved in formation of the bond. So here, so nitrogen in the formation of ammonia, we have here in the formation of ammonia. So 3 electrons are shared in the formation of ammonia by nitrogen. 3 electrons are already shared. Now remaining 2. The two, okay, so this is the 2 lone pair of electron which is not shared with the with any of the hydrogen atom. And then, so here this a lone pair of electron present on ammonia molecule, that is on nitrogen, can be donated to the hydrogen ion, because hydrogen ion has no electron, so it can lead to the formation of coordinate bond. We show the coordinate bond with the arrow heading from the donor to the acceptor. So here donor is nitrogen and acceptor is hydrogen. So remember here the formation of the coordinate bond. So nitrogen is the donor atom and hydrogen ion is the acceptor atom. So here we see that here both of them fulfill the octet and the doublet state. So this is the formation of coordinate bond. So here I've just shown you the example of formation of ammonium radical, taking the example here. Okay, so I have illustrated on the board. Now let us look at another example, formation of sulfuric acid, H2SO4 here. So we see that here the donor atom is only sulfur. So sulfur is donating the lone pair of electron to 2 oxygen atoms forming H2SO4. So here this also illustrates the formation of coordinate bond. Now what are the conditions for the formation of coordinate bond? So there are some conditions. Okay, so let's look at the two conditions for the formation of coordinate bond. Number one is one of the 2 atoms must have at least 1 lone pair of electron. So here in the formation of the ammonium radical, so here we have seen that, okay, so yeah, formation of ammonium radical, we saw that nitrogen has the lone pair of electron. The nitrogen in ammonia molecule has the lone pair of electron, and then so this nitrogen has already attained the octet state, and then so this lone pair of electron can be donated to the atom or the ion which is in need of the electron. Example, we have ammonia. Similarly, we have the water. So in case of water, the lone pair of electron is present on oxygen, so which can be given or which can be donated to hydrogen ion, leading to the formation of hydronium ion. So this is one condition. And the second one is another atom should be short of at least a lone pair of electron to complete octet or doublet. So here the acceptor is hydrogen ion. So hydrogen ion is in need of 2 electrons to complete the doublet state. Similarly here in the formation of hydronium ion, hydrogen ion is in need of 2 electrons to complete its doublet state. So these are the 2 conditions required for the formation of coordinate bond. Now, so that's all for the day. So lesson closure. So today basically you have studied if there is no electronegativity difference between the 2 atoms, it leads to the formation of pure non-polar covalent bond. So if there is no difference in electronegativity, then it leads to the formation of non-polar covalent bond. If there is a small difference of electronegativity, then it leads to the formation of polar covalent bond. And if there is a large difference of electronegativity between the 2 atoms, it leads to the formation of ionic bond. So let me show you here, there on the screen. If the difference of electronegativity is 0, then the type of bond form will be purely covalent. If it is intermediate, that is between 0.4 and 1.8, then the bond form will be polar covalent bond. And if the difference of electronegativity between the two atoms is more than 1.8, then the nature of bond form will be purely ionic. So the difference in the value of electronegativity between the two combining atoms determines the nature of bond. And then, so let us do some exercises. From its position in the periodic table, determine which atom in each pair is more electronegative. And then similarly, we have which bond is the most polar. And then what is the significance of dipole moment? And you can learn, or you can find some more information about the polarity and electronegativity by visiting the website on YouTube. Video 1, review of electronegativity, and video 2, review of electronegativity's role in molecular polarity. So the link will be shared in your Google Classroom. So you can go to the link and then you can watch the video for more information. So thank you for attending this lesson, and I will see you in the next lesson. Thank you and Kadinche.